Hi guys, in this video we're going to go over the key features of rational functions. So this should look familiar from Math 3, but if not, these are your notes, and I also uploaded a little cheat sheet that has some tips on how to find these key features. And the Delta Math assignment will also have videos that you can watch. I also can guarantee you that if you looked up any one of these things on YouTube with the word rational function next to it, a bunch of videos would pop up. This is a really common topic. All right, so first thing, when you have the function, it will be given to you in one of these two forms. It is super helpful to have them both. So if you're given the standard form, go ahead and factor it. And if you have the factored form, it's easy to just multiply them out and get the standard form. We definitely at least need the factored form. We can get away without standard, but we need the factored form. So horizontal asymptote has to do with whether it is top heavy, bottom heavy, or the same. And so what that is referring to is the degree of the numerator compared to the degree of the denominator. So in standard form, you're looking for your highest exponent. Your highest exponent is the degree. In factored form, you're looking at how many x's are getting multiplied in each spot. So with the horizontal asymptote, I can see from my standard form that I have x squared as my highest exponent. It's the same in the numerator and the denominator. So that is my leading term. And I can get the same piece of information from the factored form, x times x, x times x, so it's the same. So when it's the same, we have to reduce the leading coefficients. So that's why it's a little bit easier in standard form, because I can tell my numerator has a leading coefficient of 2. I mean, you can see it here also, but depending on what the factors are, it might just be a little bit trickier. But basically, you just have to multiply whatever the GCF was times the first term here times the first term there, and just make sure that's your leading coefficient. So 2 over 1 reduces to 2. So for this particular example, my horizontal asymptote is the line y equals 2. If it was top heavy, if my numerator had a higher exponent, there's no horizontal asymptote. When it's bottom heavy, if there's more x's in the denominator, then it's always 0. All right, vertical asymptote and whole and x-intercept, honestly, we want the factored form for all of these. So the vertical asymptote are any numbers that make the denominator equal 0 and the factor does not cancel out. So if you look at my example here, the factored form, I have 2 factors in the denominator. So think about what number would make x plus 4 0. It would be 0 if x was equal to negative 4. All right, I have another factor here of x plus 3. So what number is going to make x plus 3 0? That number would be negative 3. So if you notice, the x plus 3's will actually cancel, which means that x that equals negative 3 is the x value of the whole. The one in the denominator that doesn't cancel, that is your vertical asymptote. So we have a vertical asymptote when x is equal to 4, and we have a whole when x is equal to negative 3. Now, a whole is a point. A whole is technically an ordered pair. So far, what I have found is the x value. Now I need to find the y value. So to find the y, we take the pieces that are left over, and we're going to plug that x number in. So I'm just going to kind of write down what my simplified version is. So my simplified version is 2 times x minus 5 over x plus 4. And wherever I see x, I'm going to plug in -3. So that'd be 2 times -3 minus 5 over -3 plus 4. So my numerator, that would be -8 times 2 is -16. That would be 1, so -16. All right, the x-intercept are whatever factors are remaining in the numerator. We set those factors equal to 0. And so there can be more than one. It's possible to have more than one x-intercept. Now, it's also possible to have no x-intercept. So keep that in mind too. There's no rule for how many of each of these things there's supposed to be. So if I look at my numerator, I still have an x minus 5 in the numerator. So whatever makes that factor 0 is where I have an x-intercept. And so that number would be 5. So my x-intercept is the point 5, 0. All right, the y-intercept, you can use either form, but standard form is a lot easier because it doesn't have to be simplified really too much. But to find the y-intercept, you always plug 0 in for x. So I'm going to use the standard form for this one. So I use standard for this one, and I also use standard for this one. But it's possible to use factored form for both of those. You just have to be careful. So the y-intercept is found by plugging in 0 wherever I see x. So in standard form, that would become 0, that would become 0. My numerator would just be -30. That would become 0, that would become 0. My denominator would be +12. So -30 over 12 reduces to -15 over 6. So that is the y-intercept of this function, the point 0 and -15 over 6. All right, and you would get the same thing if you plugged 0 into the factored form. You don't have to worry about those. But 0 minus 5, there's your -5 times 2 is -15. Nope, I lied. Yeah, I guess you need this too. Just kidding. Yeah. So plug in, oh no, I can keep going. Just kidding. I can keep simplifying this. I can divide that again. I can divide those both by 3. That's why. So if you plug 0 into this, that would be -5 times 2 is -10. If you plug 0 into this, that would be 4. And then you could reduce that and it would be the same. All right, so I'll go through one more example of all of these, just kind of a little bit quicker. This way you at least have 2 examples to look at. All right, so there's my rational function. I am going to factor it. So the numerator is already linear, that doesn't have to be factored. All right, so horizontal asymptote, I'm looking for top heavy, bottom heavy, or the same. So I can tell from my standard form, there's my highest exponent, so it's bottom heavy, but I can also tell from factored form I have 2 on the bottom, so it's bottom heavy. Every single time it's bottom heavy, your horizontal asymptote is at 0. All right, my vertical asymptote, I can see here that this factor, if x is equal to 3, it'll make that factor 0. And over here, if x is equal to -3, that factor would become 0. Because those cancel, this one is a whole. The one that doesn't cancel is a vertical asymptote. So I have a vertical asymptote at x is equal to 3. To finish finding the y value of the whole, I have to look at the simplified version and plug -3 in wherever I see x. Whenever you completely cancel the numerator, you have to make sure you put 1 as a placeholder. So my simplified version is 1 over x minus 3. So I'm going to plug -3 into that. So -3 minus 3 is -6. So my whole is at the point -3, -1 over 6. All right, my X-intercept, I don't have any factors left in the numerator. So X-intercept, I actually have no X-intercepts, because 1 cannot equal 0. And that should make sense because I have a horizontal asymptote. Y equals 0 is the x-axis, so that means my graph is not crossing that line anyway. So it could make sense anytime you have a horizontal asymptote at 0, it's very possible that you'll have no x-intercept. All right, y-intercept. I'm taking whichever version you feel like using and plugging in 0 wherever I see x. So if I use the factored version, that would be -1/3. And that would be the same thing I got here. That would reduce to -1/3.